Hello everyone, I am Yu Huang. The topic of the MOOC today is Introduction to DCN. Now I will introduce DCN to all of you. Let's begin with the basic concepts of DCN and then the principles and application scenarios of outband DCN and in-band DCN. Upon completing these parts, you will understand in which circumstance a specific DCN solution is used. Finally, I will introduce the packet structure and implementation mechanism in various solutions for your further research. First, let's look at the definition of DCN. DCN refers to a device management system that provides communication channels for managing NEs in a centralized manner to achieve remote management and maintenance of NEs. What is DCN? DCN is a network that provides centralized management for devices distributed on the network. Operators can monitor each network device at the NMS center using the DCN. This is a typical networking mode of DCN, which consists of the NMS, gateway NEs, GNEs, non-GNEs, and connections between them. The NMS access modes include gateway access and direct access, as shown in the following figure. Gateway access. The NMS accesses a non-GNE through the GNE. Direct access. The NMS directly accesses a GNE. In practice, a specific DCN solution is used to set up a DCN depending on the network type. The following describes the difference between the outband DCN and in-band DCN. Simply speaking, an SDH network uses outband DCN features, and a PSN network uses in-band DCN features. What is outband DCN? Outband DCN is a DCN networking mode that does not use service bandwidths for data communication. The ECC logical channel of the outband DCN is established based on a DCC or GCC physical channel to implement operation, administration, and maintenance, OAM, communication between NEs. Based on device types, outband DCN can be classified as follows. 1. The following figure shows a typical networking mode of the Huawei ECC solution. Subnets 1 and 2 are independent of each other, and there is no DCC channel between them. In this case, extended ECC channels can replace DCC channels to achieve communication between subnets 1 and 2. 2. The following figure shows a typical networking mode of the IP over DCC solution. A third-party network is located between subnets 1 and 2, and network management information is transparently transmitted using IP over DCC to achieve communication between subnets 1 and 2. 3. The following figure shows a typical networking mode of the OSI over DCC solution. Except the used protocol, the networking mode of the OSI over DC solution is the same as that of the IP over DCC solution. 4. The following figure shows a typical networking mode of the DCC transparent transmission solution. MSTP devices still use original DCC bytes as DCC channels. In addition, a route used for transparently transmitting DCC bytes of MSTP devices needs to be set up on the transmission network of the third-party device. 5. The following figure shows a typical networking mode of the solution for transparently transmitting OAM information on MSTP networks. MSTP devices can use various OAM protocols for self-networking and interworking with other devices. In addition, they can transparently transmit management information of other networks. The DCN solution is provided to implement these two functions, enabling the NMS to manage devices connected to it. What is in-band DCN? In-band DCN is a DCN networking mode that uses a portion of service bandwidths for data communication. Ethernet service bandwidths on FE/GE ports are used to transmit network management information. The following figure shows a typical networking mode of the in-band DCN solution. In-band DCN channels are differentiated from Ethernet service channels based on VLAN IDs. Compared with the outband DCN, An in-band DCN occupies service channels but does not require additional devices. Based on preceding contents, we have a certain understanding of DCN application scenarios. Now let's make a brief summary. Next, I will introduce the packet structure and implementation mechanism in different DCN solutions. Let's see the Huawei ECC solution first. The following figure shows the structure and implementation mechanisms of the Huawei ECC packet on the SDH network. On the SDH network, an NE uses a dedicated DCC interface. Compared with the SDH network, the PSN network uses the FE-GE service interface instead of the DCC interface. This is the only difference between the PSN network and SDH network. On both the SDH network and PSN network, the Huawei ECC packet supports only gateway access. IP over DCC packet solution. Gateway access. As shown in the figure, in gateway access mode, the IP over DCC packet on the SDH network is different from the Huawei ECC packet in the following aspects. 1. The IP protocol instead of the Huawei ECC protocol is used. 2. The IP routing table instead of the network layer routing table is used. 3. An IP address instead of a MAC address is used. 4. The packet is reported to the application layer through the transport layer instead of L4. Other features are the same. In gateway access mode on the PSN network, steps for encapsulating the OAM management packet into Ethernet service data and adding a VLAN ID are added for the IP over DCC packet. In addition, interfaces for carrying NMS information are different. These are differences between the IP over DCC packet on the PSN network and that on the SDH network. Other features are the same. Direct access. Compared with gateway access, direct access on the SDH network uses original GNEs as common forwarding NEs to forward packets on the network layer. In direct access mode on the PSN network, steps for encapsulating the OAM management packet into Ethernet service data and adding a VLAN ID are added for the IP over DCC packet. In addition, interfaces for carrying NMS information are different. These are differences between the IP over DCC packet on the PSN network and that on the SDH network. Other features are the same. OSI over DCC packets. Gateway access. In gateway access mode on the SDH network, the OSI over DCC packet uses the OSI protocol, whereas the IP over DCC packet uses the IP protocol. This is the only difference between them. Other features are the same. Direct access. In direct access mode on the SDH network, the OSI over DCC packet is the same as the IP over DCC packet, except for the used protocol. At last, let's conclude the differences between various DCN solutions.